this lecture and find out the area of the green shape using two different methods. In the drawing we have a circle. Inside this circle we have triangle ABC. Side AB of this triangle equals to 13 units. Side BC equals to 14 units. And side AC of this triangle ABC equals to 15 units in length. Our mission is to find out the area of this green shape. From the drawing it is very easy to see that the area of the green shape equals to the area of the circle minus the area of triangle ABC. So we start with the first method. In the first method I will present to you rule number 4 and we will implement rule number 4 in our drawing. According to rule number 4, we have here triangle ABC. The length of side AB is A units, side BC equals to B units in length, and side AC equals to C units in length. And according to this rule number 4, the area of this triangle ABC equals to, first of all, the semi-perimeter of this triangle ABC equals to the perimeter over 2. The perimeter of this triangle ABC equals to A plus B plus C. That is the sum of its side lengths. And when we will divide the perimeter by 2, we get the semi-perimeter. So the semi-perimeter of this triangle ABC S, the semi-perimeter S equals to A plus B plus C over 2. The length of side AB is 8, the length of side BC is B, and the length of this side AC of this triangle ABC equals to C units. So the area of this triangle ABC according to the new rule number 4 equals to the square root of S is the semi-perimeter times S times S minus A times S minus B times S minus C. Okay, so we can actually implement rule number 4 in our drawing in order to find out the area of this triangle ABC. So first of all, we define the length of side AB as A, and we know that A equals to 13. We define the length of side BC as B, and we know that B equals to 14 according to what is given as the question. And finally we define the length of side AC of this triangle ABC as C, and we know that C equals to 15 units in its length. In the next step we find out the semi-perimeter of this triangle ABC. According to the formula, according to rule number 4, the semi-perimeter of this triangle ABC that could be any triangle equals to A plus B plus C over 2. That is to say, it is the sum of its side lengths over 2. So therefore, the semi-perimeter of this triangle ABC S must be equal to A plus B plus C over 2. So write it down. The semi-perimeter S of triangle ABC according to rule number 4, it will be equal to A plus B plus C over 2. A is 13 plus B that is 14 plus C that is 15 over 2. So 13 plus 14 is 27, 27 plus 15 over 2. 27 plus 15 is 42, and 42 over 2 is 21. So finally we found out that the semi-perimeter S of our triangle ABC equals to 21 units. According to our definition, A equals to 13, B equals to 14, and C equals to 15. The area of our triangle ABC according to rule number 4 is equals to the square root Inside the square root we have S, that is the semi-perimeter, that is 21, times S minus A, times S minus B, times S minus C. So the area of our triangle ABC, according to rule number 4, it will be equal to the square root of S. S is 21, times S minus A. S is 21 and A is 13, therefore S minus A in total equals to 21 minus 13 times S minus B. S is 21, B is 14, therefore S minus B in total equals to 21 minus 14 times S minus C. Again, S is 21, C is 15, therefore S minus C in total equals to 21 minus 15. So the area of triangle ABC, according to rule number 4, it will be equal to the square root of 21. 21 minus 14 is 8, times 21 minus 14 is 7, times 21 minus 15 is 6. So the area of triangle ABC equals to the square root of 21 times 8 times 7 times 6. Here we'll substitute 21 by 3 times 7, and we get that the area of triangle ABC will be equal to the square root of, again, 21 is 3 times 7 times 8. We substitute 8 by 2 times 2 times 2. Times 7 times 6. We substitute 6 by 2 times 3. So actually found out that the area of this triangle ABC, according to rule number 4, it is equals to the square root of 3 times 7 times 2 times 2 times 2 times 7 times 2 times 3. So the area of triangle ABC equals to 3 times 3, the square root of 3 times 3, we have 2 times 3 appears in this formula twice, so it is 3 times 3. We have 7 that also appears twice in this equation, so it is 7 times 7. We have 2 times 2, and we have here 2 times 2 again. So the area of triangle ABC is equals to the square root of 3 times 3 is 3, the square root of 7 times 7 is 7, times the square root of 2 times 2 is 2, and again we have the square root of 2 times 2, that is 2. So in conclusion, we found out that the area of triangle ABC equals to 3 times 7, this is 21, 21 times 2 times 2. 21 times 2 is 42, and 42 times 2 is 84. So in total, the area of triangle ABC is equals to 84 square units. Repeat again. The area of this triangle ABC equals to 84 square units. We know that the area of the green shape equals to the area of the circle minus the area of triangle ABC. Now we have to find out the area of this. We have to find out the area of the circle. In order to find out the area of the circle, we have just to find out the radius of the circle. We'll use a new rule number 6, in order to find out the radius of this circle that blocks triangle ABC. According to rule number 6, the radius of a circle that blocks triangle ABC that could be any triangle is equals to R equals to A times B times C over 4 times the area of triangle ABC that is blocked by the circle. So here we have a circle. Inside this circle we have triangle ABC that is blocked by the circle. We know that the length of side AB is A, side BC equals to B units in its length, and side AC equals to C units in its length. We define the radius of this circle as capital R. So according to this rule number 6, the value of capital R, that is to say the radius of this circle, will be equal to A times B times C, that is the multiplication of the side lengths of this triangle ABC by each other, over 4 times the area of this triangle ABC that is blocked by this circle. So we can actually implement rule number 6 in our drawing. Why? Because in our drawing we have this circle that blocks triangle ABC. So the radius of this circle, we define the radius of this circle as capital R. So the radius of this circle, capital R, according to rule number 6, equals to A times B times C. That is the multiplication of the side lengths of this triangle ABC by each other, over 4 times the area of this triangle ABC that is blocked by the circle. Repeat again. According to rule number 6, the radius of this circle that blocks triangle ABC will be equal to A times B times C over 4 times the area of triangle ABC that is blocked by the circle. So the radius of the circle must be equal to A, that is 13, times B, that is 14, times C, that is 15, over 4 times the area of triangle ABC. We have already found out that the area of triangle ABC equals to 84 square units. Here we divide both the numerator and the denominator of this expression by 14. In the numerator we have 14, so 14 over 14 is 1. So in the numerator we left only with 13 times 15 over, in the denominator we have 4 times 84. We have to divide 84 by 14. 84 over 14 is 6. So in total, in the denominator we have 4 times 6. In the next step, we will divide both the numerator and the denominator of this expression by 3. In the numerator we have 13 times 15, and 15 over 3 is 5. So in total, in the numerator we have 13 times 5 over 4 times 6, and 6 over 3 is 2. So in total, in the numerator, after we divided it by 3, we have 4 times 2. 13 times 5 is 65, and 4 times 2 is 8. So in total, we found out that the radius of this circle that blocks triangle ABC, the radius capital R, equals to 65 over 8 units. Now it is very easy to find out the area of this circle. The area of any circle equals 2 pi times the radius squared. Okay, I repeat again that the area of this green shape equals to the area of the circle minus the area of triangle ABC. I'll write it down again. The area of the green shape equals to the area of the circle minus the area of triangle ABC. So the area of the green shape equals to the area of the circle. The area of the circle is pi r squared minus the area of triangle ABC. We have already found out that the area of triangle ABC equals to 84 square units. And we have already found out that the radius of the circle r equals to 65 over 8. Therefore, it will be equals to pi, and r is 65 over 8. Therefore, r squared is 65 over 8 squared minus 84. That is the area of triangle ABC. This expression in total equals to 207.394 square units minus 84. 207.394 minus 84 equals in total to 123.394 square units. So we actually found out that finally that the area of the green shape in total it is equals to 123.394 square units. Okay, and that is the answer to the question. In the next step, I will present to you how to find out the area of this green shape according to the second method. In the second method, we will do a construction. That is to say, from point A, we will draw perpendicular on BC. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A and BC as M. We will define the length of side AM as H, or the perpendicular AM as H. We define the length of line segment BM or side BM as X. According to what is given as the equation, the side BC of triangle ABC equals to 14 units. According to definition, BM equals to X. Therefore, CM must be equal to CB minus MB. So CM equals to CB, that is 14, minus MB, that is X. So in total, CM equals to 14 minus X. CM equals to 14 minus X. In the next step, I will copy the right triangle A and B in a new page, and we will implement on this right triangle A and B the Pythagoras theorem. By PT is the abbreviation for Pythagoras theorem. So actually, this is the right triangle A and B that they copied from the original drawing. AM equals to H and BM equals to X according to our definition. The hypotenuse AB equals to 13 units according to what is given as the question. By PT is abbreviation for Pythagoras theorem. So according to the Pythagoras theorem, in this right triangle, triangle ABM, AB squared equals to AM squared plus BM squared. AB is 13, therefore AB squared is 13 squared, that is 169, and it is equals to AM squared. AM is H, therefore AM squared is H squared, plus BM squared. BM is X, therefore BM squared is X squared. So in conclusion, according to equation number 1, we found out that 169 equals to H squared plus X squared. We subtract X squared from this equation, equation number 1, and we get that according to this equation, equation number 1, H squared equals to 169 minus X squared. In the next step, I will copy the right triangle, triangle AMC in a new page, and we will implement the Pythagoras theorem on this right triangle, triangle AMC. By PT is the abbreviation for Pythagoras theorem. So actually, this is the right triangle, triangle AMC that I copied from the original drawing. According to the Pythagoras theorem, in this triangle, triangle AMC, AC squared equals to AM squared plus MC squared. AC is 15, therefore AC squared is 15 squared, that is 225. And it is equals to AM squared. AM is H, therefore AM squared is H squared, plus MC squared. MC is 14 minus X, therefore MC squared is 14 minus X squared. Here we subtract 14 minus X squared from this equation, equation number 2. And we get that according to equation number 2, H squared equals to 225 minus 14 minus X squared. This is according to equation number 2, but we have already found out that according to equation number 1, H squared equals to 169 minus X squared. So we have two different expressions for H squared. Therefore, we create equation number 3 that states that H squared according to equation number 1 must be equal to H squared according to equation number 2. So H squared according to equation number 1 equals to 169 minus X squared, and it must be equal to H squared according to equation number 2. So H squared according to equation number 2 equals to 225 minus 14 minus X squared. So according to equation number 3, we found out that 169 minus x squared equals to 225 minus, we'll open the brackets, we'll calculate the value of 14 minus x squared. 14 minus x squared equals to 14 squared, that is 196, plus x squared minus 2 times 14x is minus 28x. So actually found out that according to equation number 3, $169 minus x squared equals to 225. Here we'll open the brackets. We'll get here minus 196 minus x squared. Minus and minus is plus, so it is plus 28x. So here we have minus x squared on both sides of the equation, so minus x squared will get cancelled. So in this side of the equation we left only with $169, that is equals to 225 minus 196 is 29 plus 28x. In conclusion, I found out that according to equation number 3, 169 equals to 29 plus 28x. So here we subtract 29 from this equation, equation number 3, and we get that according to equation number 3, 169 minus 29 is 140, so 140 equals to 28x. Here we divide this equation, equation number 3, by 28, and we get that x equals to 140 over 28 is 5, so x equals to 5. According to equation number 1, we found out that that x squared equals to 169 minus x squared. That is to say, x squared equals to 169 minus x squared, but x is 5, therefore x squared is 5 squared, that is 25. So finally we found out that h squared equals to 169 minus 25. So h squared equals to 169 minus 25 is 144. So we found out that according to equation number 1, h squared equals to 144. We take a root out of this equation, and we get that h equals to the square root of 144, that is 12. So we found out that h equals to 12 units in its length. We will define the center of this circle as H, as O. We will join points O and A together by straight line. Point O is the center of the circle, point A is the point on the circle itself, therefore OA is the radius of the circle. We define the radius of this circle as capital R, therefore OA equals to capital R. We will extend the radius AO by straight line until it touches the circle. We define the touching point of the extended radius AO with the circle as point P. We extended the radius AO, that is a straight line, by straight line. When we extend the straight line by straight line, the result is a straight line. So AP is one big straight line. AP is not only a straight line, but it is also a chord. So AP is a chord that passes from point O, that is the center of the circle. and any chord that passes through the center of the circle must be the diameter of the circle. So AP is the diameter of the circle, so can I tell that AP is the diameter of the circle? And the diameter of any circle is twice as long as the radius. The radius is r, therefore the diameter AP is 2r. Here, point O is the center of the circle, point P is the point of the circle itself, therefore OP is the radius of the circle, that is equal to capital R. So in total, you can say that AP equals to R plus R, that is 2R. In the next step, we will join points P and C together by a straight line. By joining points C and P, we can get the peripheral angle ACP. This peripheral angle ACP, rests on AP, that is the diameter of the circle. And therefore, peripheral angle ACP must be equal to 90 degrees according to rule number 7. According to rule number 7, if a peripheral angle rests on the diameter of the circle, then it is equal to 90 degrees. Here we have peripheral angle ACB that rests on AB, that is the diameter of the circle, therefore peripheral angle ACB equals to 90 degrees. So according to rule number 7, any peripheral angle that rests on the diameter of the circle must be equal to 90 degrees. Therefore, we can implement rule number 7 in our drawing. Why? Because in our drawing we have peripheral angle ACP that rests on AP, that is the diameter of the circle. Therefore, this peripheral angle ACP must be equal to 90 degrees according to rule number 7. So this peripheral angle ACP equals to 90 degrees. Then actually have also another rule number 8. According to rule number 8, peripheral angles that rest on the same chord are equal to each other. In the drawing we have peripheral angle ADB that rests on chord AB, and we have also peripheral angle ACB that rests on the same chord AB. Therefore, those two peripheral angles that rest on the same chord must be equal to each other. So if this peripheral angle ADB equals to theta, then the other peripheral angle ACB that rests on the same chord AB must be also equal to theta. So we actually can implement rule number 8 in our drawing. Why? Because in our drawing we have a peripheral angle APC that rests on chord AP. And we have another peripheral angle ABC that rests on the same chord AC. Therefore, those two peripheral angles that rest on the same chord AC must be equal to each other. So if we define peripheral angle APC as theta, then the other peripheral angle ABC that rests on the same chord AC must be also equal to theta. In the next step, we will focus on the right triangle APC. In this right triangle APC, this angle equals to theta, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees, it is equals to 180 degrees. That is the sum of the angles in any triangle. Likewise, we focus on the right triangle A and B. In the right triangle A and B, this angle equals to theta, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus theta. In the next step, we will prove that the right triangle, triangle A and B, is similar to the right triangle, triangle APC. We will prove that those two right triangles are similar to each other. So I'll write it down. The right triangle, triangle A and B, this right triangle is similar to the right triangle, triangle APC. So why those two right triangles are similar to each other? First of all, those two angles are both equal to theta, therefore they are equal to each other. So this angle is angle ABM, and it is equals to this angle, angle APC, and triangle ACP. Repeat again. Angle ABM in triangle AMB equals to angle APC in triangle ACP. They are both equal to theta, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, therefore they are equal to each other. So this is angle AMB. And it is equals to this angle, angle ACP. Repeat again. Angle A and B in triangle ABM equals to angle ACP in triangle APC. They are both equal to 90 degrees, therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So this is angle MAB. And it is equals to this angle, angle PAC. Repeat again. Angle MAB in triangle ABM equals to angle PAC in triangle ACP. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So we actually proved that all the triangles in triangle ABM are correspondingly equal to all the triangles in triangle APC. Therefore, we actually succeeded to prove that those two right triangles are similar to each other according to angle similarity rule. So I'll write it down. We actually proved that the right triangle, triangle A and B, is similar. This is the sign of similar to the right triangle, triangle ACP. And they are similar to each other according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. That AB in triangle A and B over AP in triangle ACP is equals to AM in triangle A and B over AC in triangle APC. Repeat again, we derive that AB over AP equals to AM over AC. AB is 13 over AP is 2R, it is the diameter of the circle, and it is equal to AM. AM is 12 over AC is 13 over AC is 15. Here AC is 15. Okay, so conclusion found out that 14 over 2R equals to 12 over 15. Here we cross multiply this equation and we get that 13 times 15 equals to 12 times 2R. Here we will divide this equation by 12 and we'll get that 13 times 15 over 12 equals to 2R. Here we'll divide this equation by 2 and finally we'll get that the radius of the circle R equals to 13 times 15 over 2 times 12. So here we will divide both the numerator and the denominator of this expression by 3 and we get that in the numerator we have 13 times 15 over 3 is 5. So in total in the numerator after we divided by 3 we have 13 times 5 over the denominator we have 2 times 13 over 3 is 4. So in total in the denominator we have, after we divided by 3 we have 2 times 4. 13 times 5 is 65 and 2 times 4 is 8. So actually found out that the radius of this circle R equals to 65 over 8 units. Repeat again, the area of the green shape equals to the area of the circle minus the area of triangle ABC. So I write it down again. The area of the green shape is equals to the area of the circle minus the area of triangle ABC. The area of the circle equals to pi r squared minus the area of triangle ABC. What is the area of triangle ABC? The area of the triangle ABC equals to the base of the triangle, that is BC, times the height to the base, that is H, over 2. Repeat again, the area of this triangle ABC equals to the base of the triangle, that is BC, times the height to the base, that is H, over 2. So the area of the circle is pi times r squared. R is 65 over 8, therefore r squared is 65 over 8 squared. So the area of the circle in total equals to this expression, pi times 65 over 8 squared, minus the area of triangle ABC equals to BC equals to 14 units, times H is 12, over 2. So the area of the green shape in total is equals to this expression in total it is equals to 207.394 square units minus the area of triangle ABC. The area of triangle ABC equals to 14 over 2 is 7, and 7 times 12 is 84. So the area of triangle ABC equals to 84 square units. So the area of the ring shape in total it is equals to 207.394 minus 84. 207.394 minus 84 equals to 123.394 square units. So the area of the ring shape in total, according to the second method, it is equals to 123.394 square units. And that is the answer to the question. Repeat again, the area of this ring shape equals to 124.394 square units. So in the next step, I'll summarize the lecture. We start with the first method, of course. So in the drawing we have a circle. Inside this circle we have triangle ABC. We know that side AB of triangle ABC equals to 13 units in length, side BC equals to 14 units in length, and side AC equals to 15 units in length. Our mission is to find out the area of this ring shape. From the drawing it is very clear that the area of the ring shape equals to the area of the circle minus the area of triangle ABC. So we start with the first method. In the first method I presented to you a new rule and we implemented the new rule in our drawing. According to the new rule, we have here triangle ABC. The length of side AB of this triangle, triangle ABC equals to A units, side BC equals to B units in its length, and side AC equals to C units in its length. The semi-perimeter of this triangle, triangle ABC, equals to the perimeter over 2, and the perimeter of this triangle equals to the sum of its side lengths, that is to say it is A plus B plus C, and you will divide the perimeter by 2, you get the semi-perimeter S. So the semi-perimeter of this triangle, triangle ABC, equals to A plus B plus C over 2. Again, side AB equals to A, side BC equals to B, side AC equals to C. So according to this rule number 4, the area of this triangle, triangle ABC equals to the square root of S. S is the semi-perimeter, times S minus 3 times S minus B times S minus 3, all under the root. You can implement rule number 4 in our drawing. One, because in our drawing, first of all, we define side AB as A and A equals to 13. We define side BC as B and B equals to 14. And we define side AC of this triangle, triangle ABC as C and C equals to 15 according to what is given us the question. First of all, we found out the semi-perimeter of this triangle, triangle ABC. According to rule number 4, the semi-perimeter of this triangle, triangle ABC equals to A plus B plus C over 2. Repeat again. The semi-perimeter S of triangle ABC equals to A plus B plus C over 2. A is 13, B is 14, and C is 15, all divided by 2. 13 plus 14 is 27, 27 plus 15 is 42, and 42 over 2 is 21. So I actually found out that the the perimeter of this triangle ABC equals to 21 units. According to our definition, A equals to 13, B equals to 14, and C equals to 15. A, B, and C are the side lengths of this triangle ABC. And according to rule number 4, the area of triangle ABC equals to the square root of S times S minus A times S minus B times S minus C. S is 21, A is 13, B is 14, and C is 15. So the area of triangle ABC, according to rule number 4, equals to S, that is 21, S minus A is 21 minus 13, S minus B is 21 minus 14, S minus C is 21 minus 15. So the area of triangle ABC equals to the square root of 21 times 21 minus 13 is 8, 21 minus 14 is 7, and 21 minus 15 is 6. So the area of triangle ABC equals to the square root of 21 times 8 times 7 times 6. So the area of triangle ABC equals to 21. Here we substitute 21 by 3 times 7 times 8. We substitute 8 by 2 times 2 times 2 times 7 times 6. We substitute 6 by 2 times 3. So we found out that the area of triangle ABC equals to 21 is 3 times 7, and 8 is 2 times 2 times 2 times 7 times 6. 6 is 2 times 3. So we arrange the digits in a different way, and we got that the area of triangle ABC equals in total to the square root of 3 times 3 times the square root of 7 times 7 times the square root of 2 times 2. We have 4 times 2, so it is 2 times 2 times 2 times 2. The square root of 3 times 3 is 3, the square root of 7 times 7 is 7, the square root of 2 times 2 is 2, and we have here again the square root of 2 times 2 is 2. So we actually found out that the area of triangle ABC in total equals to 3 times 7, that is 21, 21 times 2 is 42, and 42 times 2 is 84. So in total we found out that the area of this triangle ABC equals to 84 square units. Then I presented to you rule number 6, and we implemented rule number 6 in our drawing. According to rule number 6, the radius of a circle that blocks triangle ABC equals to this expression. Here we have a circle. Inside this circle we have triangle ABC. We know that in this triangle ABC, side AB equals to A units in its length, side BC equals to B units in its length, and side AC equals to C units in its length. We define the radius of this circle that blocks triangle ABC as capital R. So according to this rule number 6, R equals to A times B times C, that is the multiplication of the side lengths of this triangle ABC by each other, over 4 times the area of this triangle ABC. So actually we can implement rule number 6 in our drawing, because in our drawing we have this circle that blocks triangle ABC. According to rule number 6, the radius of this circle, capital R, we define the radius of this circle as capital R. Capital R must be equal to A times B times C, that is the multiplication of the side lengths of this triangle ABC by each other, over 4 times the area of this triangle ABC. And again, according to rule number 6, the radius R of the circle that blocks triangle ABC must be equal to A times B times C over 4 times the area of triangle ABC. We have already found out that the area of triangle ABC equals to 84 square units. So the radius capital R of the circle that blocks triangle ABC equals to A times, that is 13, times B, that is 14, times C, that is 15, over 4 times the area of triangle ABC. Again, the area of triangle ABC is 84. So here we divided both the numerator and the denominator of this expression by 14. In the numerator we have 14, so 14 over 14 is 1. So in the numerator after we divided by 14, we left only with 13 times 15 over 4 times 84 over 14 is 6. So in total, in the denominator we have 4 times 6. After we divide it by 14, we left only with 4 times 6. Then we divided both the numerator and the denominator of this expression by 3. So in the numerator we have 13 times 15 over 3 is 5. So in total, in the numerator after we divided by 3, we left only with 13 times 5 over 4 times 6. We divided the denominator by 3, so it is 4 times 6 over 3 is 2. So after we divided the denominator by 3, we left only with 4 times 2. So the radius of the circle that blocks triangle ABC equals in total to 13 times 5, that is 65, over 4 times 2, that is 8. So the radius R equals to 65 over 8 units. The radius of this circle, capital R, equals to 65 over 8 units. What is the area of the circle and what is the area of this green shape? The area of this green shape, from the moment is very easy to see that the area of the green shape equals to the area of the circle minus the area of triangle ABC. Repeat again. The area of the green shape in total it is equals to the area of the circle minus the area of triangle ABC. The area of the circle equals to pi r square. We have already found out that the area of triangle ABC is 84 square units. We have already found out that the radius of the circle capital R equals to 65 over 8, therefore capital R square is 65 over 8 square times pi. So in total, the area of the circle equals to this expression minus the area of triangle ABC, that is 84 square units. This expression in total equals to 207.394 square units minus 84, that is the area of the triangle ABC. So 207.394 minus 84 equals to 123.39 square units. So if we found out that the area of this green shape equals to 123.394 square units. We finished with the first method. In the next step, I presented to you how to find out the area of this green shape according to the second method. In the second method, we did the construction, that is to say from point A we drew perpendicular on BC. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A and BC as M. Then we defined the perpendicular AM as H. We defined line segment BM as X. We know that BC equals to 14 units according to what is given as the equation. BM equals to X according to our definition. Therefore, CM equals to CB minus MC. So CM equals to CB, that is 14, minus MC, that is X. So in total, CM equals to 14 minus X. Then I copied the right triangle ABM in a new page and we implemented the Pythagoras theorem on this right triangle ABM. This is the right triangle ABM that I copied from the original drawing. AM equals to H and BM equals to X according to our definition. AB equals to 13 units according to what is given as the equation. By PT is the equation for Pythagoras theorem. So in the right triangle ABM, according to the Pythagoras theorem, AB square equals to AM square plus BM square. AB is 13, therefore AB square is 13 square, that is 169, and it equals to AM square. AM is 8, therefore AM square is 8 square, plus BM square. BM is X, therefore BM square is X square. So in total we found out that according to equation number 1, 169 equals to H square plus X square. Here we subtracted X square from this equation number 1, and finally we found out that H square equals to 169 minus X square. Okay. Then I copied the right triangle AMC in the new page and implemented the Pythagoras theorem in this right triangle AMC. This is the right triangle, triangle AMC that I copied from the original drawing. AM equals to edge, according to the definition. We've already found out that MC equals to 14 minus x and the hypotenuse AC equals to 15 units, according to what is given as the equation. By PT is the equation for Pythagoras theorem. So in the right triangle, triangle AMC, according to the Pythagoras theorem, we get that AC squared equals to AM squared plus MC squared. AC is 15, therefore AC squared is 15 squared, that is 225, and this equals to AM. AM is h, therefore AM squared is squared, plus MC squared. MC is 14 minus x, therefore MC squared is 14 minus x squared. Here we subtracted 14 minus x squared from this equation, equation number 2, and found out that according to equation number 2, h squared equals to 225 plus 14 minus x squared. This is according to equation number 2, but according to equation number 1, we have already found out that h squared equals 269 minus x squared. So we have two different expressions for h squared. Therefore, we created equation number 3 that states that h squared according to equation number 1 must be equal to h squared according to equation number 2. H squared according to equation number 1 is equals to 169 minus x squared. And it must be equal to h squared according to equation number 2. H squared according to equation number 2 equals to 225 minus 14 minus x squared. So according to equation number 3, 169 minus x squared equals to 225 minus 14 minus x squared equals to 14 squared, that is 196, plus x squared minus 2 times 14x, that is minus 28x. So we have here 169 minus x squared equals to 225. Here we open the brackets. After we open the brackets, we have here minus 196 minus x squared, minus is plus, so it is plus 28x. Plus 28x. So here we have minus x squared on both sides of the equation, so minus x squared will get cancelled. After we cancel minus x squared, in this side of the equation we left only 169. And in the other side of the equation, here we have actually 225 minus 196 is 29 plus 28x. Okay, here we have 29 plus 28x. Here we subtract the 29 from this equation, equation number 3, and finally found out that 169 minus 29 is 140. That is equals to 28x. Here we divided this equation, equation number 3, by 28, and found out that x equals to 140 over 28 is 5. So x equals to 5. According to equation number 1, h squared equals to 169 minus x squared. So h squared equals to 169 minus x squared. But x is 5, therefore x squared is 5 squared, that is 25. So in total, according to equation number 1, h squared equals to 169 minus 25. 169 minus 25 is 144. So we found out that according to equation number 1, x squared equals to 144. We took out of this equation and finally found out that h equals to the square root of 124. The square root of 144 is 12. So h equals to 12. We can write down that the height h equals to 12 units and x is equals to 5 units. Then we define the center of this circle as O. We join points O and A together by straight line. Point O is the center of the circle, point A is the point of the circle itself, therefore OA is the radius of the circle. We define the radius of this circle as capital R. Then we extended the radius AO until it touches the circle. We define the touching point of the extended radius AO with this circle as P. When you extend the straight line by straight line, the result is a straight line. So AP is a straight line that passes. So AP is not only a straight line, but it is also a chord that passes through the point O, that is the center of the circle. And you know that any chord that passes through the center of the circle must be the diameter of the circle. Therefore, AP is the diameter of the circle. We know that the diameter of any circle is twice as long as the radius. The radius is capital R, therefore the diameter AP must be equal to 2 times capital R. Okay, then we join points P and C together by a straight line. In this way, we created peripheral angle ACP. Peripheral angle ACP rests on AP, that is the diameter of the circle. And we have the rule that any peripheral angle that rests on the diameter of the circle must be equal to 90 degrees. Okay, according to rule number 7, if a peripheral angle rests on the diameter of the circle, then it is equal to 90 degrees. So here we have peripheral angle ACB that rests on AB, that is the diameter of the circle. Therefore, this peripheral angle ACB equals to 90 degrees. We actually can implement rule number 7 in our drawing. Why? Because in our drawing we have peripheral angle ACP that rests on AP, that is the diameter of the circle. Therefore, peripheral angle ACB, this angle must be equal to 90 degrees according to rule number 7. Then I presented to you rule number 8 also, and we presented rule number 8 in our drawing. According to rule number 8, peripheral angles that rest on the same chord are equal to each other. Here we have peripheral angle ADB that rests on chord AB, and we have another peripheral angle ACB that rests on the same chord called AB. So because of the fact that those two peripheral angles rest on the same chord, they must be equal to each other. So if this peripheral angle ADB equals to theta, then the other peripheral angle ACB must be also equal to theta. We can actually implement rule number 8 in our drawing. Why? Because in our drawing we have peripheral angle APC that rests on chord AC, and we have another peripheral angle ABC that rests on the same chord called AC. So those two peripheral angles are both rest on the same chord called AC, therefore they must be equal to each other. So if this peripheral angle APC equals to theta, then the other peripheral angle ABC that rests on the same chord called AC must be also equal to theta. Then we focus on the right triangle, triangle APC. In the right triangle, triangle APC, this angle equals to theta. This angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in a triangle. Likewise, in the right triangle ABM, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta. In the next step, we proved that the right triangle ABM is similar to the right triangle, triangle APC. So why those two right triangles are similar to each other? First of all, those two angles are both equal to theta, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So we proved that all the three angles in triangle ABM are correspondingly equal to all the three angles in triangle APC. Therefore, those two triangles are similar to each other according to angle similarity rule. And from the fact that those two triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that AB in triangle AMB over AP in triangle APC is equals to AM in triangle AMB over AC in triangle APC. I repeat again, we derive that AB over AP equals to AM over AC. AB is 13, AP is the diameter of the circle that is 2R, AM is 12, and AC is 15. Here we cross multiply this equation, and we found out that 13 times 15 equals to 12 times 2R. Here we divided this equation by 12, and we found out that 2R equals to 13 times 15 over 12. Here we divided this equation by 2, and finally we found out that R, the radius of this circle, capital R, equals to 13 times 15 over 2 times 12. Here we divided both the numerator and the denominator of this expression by 3. So in the numerator we have 13 times 15 over 3 is 5. So in total in the numerator we have 13 times 5, after we divided by 3. We divided the denominator also by 3. So in the denominator we have 2 times 12 over 3 is 4. So in total, after we divided this denominator by 3, we left only with 2 times 4. 2 times 4 is 8, and 13 times 5 is 65. So the radius of this circle in total, capital R, equals to 65 over 8. The radius of this circle, capital R, equals to 65 over 8. So what is the area of the green shape? Repeat again, the area of this green shape equals to the area of the circle minus the area of triangle ABC. Repeat again, the area of the green shape in total it is equals to the area of the circle minus the area of triangle ABC. Okay, so the area of the circle equals to pi r square. What is the area of triangle ABC? The area of this triangle ABC equals to the base of the triangle that is BC times the height to the base that is h over 2. Repeat again, the area of triangle ABC equals to the base BC times the height to the base that is h over 2. We have already found out that the radius of the circle capital R equals to 65 over 8. If R equals to 65 over 8, it means that R square equals to 65 over 8 square. So pi R square equals to pi times 65 over 8 square minus the area of triangle ABC. BC is 14 times h, that is 12 over 2. So this expression in total is equals to 207 minus 394 square units. Repeat again, this expression in total is equals to 207.394 square units minus the area of triangle ABC. The area of triangle ABC equals to 14 over 237. 7 times 12 is 84. So the area of triangle ABC in total equals to 84 square units. Therefore, the area of the green shape in total must be equals to 207.394 minus 84. 207.394 minus 84 equals to 123.394 square units. So in total, we actually found out that the area of this green shape, according to both methods, it is equals to 123.394 square units. Okay, thank you very much.